Welcome to the Deep Dive, the show where we try to make sense of all the rapid changes in tech and innovation. And if you follow AI at all, you know the pace is just wild right now, especially in open source. Seems like every week there's something new. Honestly, it's hard to keep track. So today we're doing a deep dive into something pretty significant that just landed on Hugging Face, the GLM-4.5 series from Z.ai. You might know them as Z.ai previously. And crucially, these models come with an MIT license. For anyone watching open access in AI, you know that's a big deal. Our goal here is simple. Cut through the hype, give you the essentials on these new models. We'll look at what makes them unique, how they perform against others, what you can actually do with them, and maybe most importantly, how you, whether you're developing stuff or doing research, might actually use them. What caught my eye initially is their focus on combining reasoning, coding, and agent abilities. Plus, this hint of them being usable locally, which, well, that's always interesting. Let's unpack it.
Yeah, it's definitely an exciting release. So the GLM 4.5 family is basically two main models right now. You've got the big one, GLM 4.5, that clocks in at 355 billion total parameters, but 32 billion are active at any one time. Then there's the smaller sibling, GLM 4.5 Air. That one's 106 billion total, 12 billion active. And like you said, the goal is pretty clear: unify reasoning, coding, and agent capabilities. They're really targeting these complex agentic applications that are popping up everywhere.
Unifying those three: reasoning, coding, agents. That sounds ambitious. I mean, what's the secret sauce there? How did Z.ai actually pull that off architecturally?
Well, what's really fascinating, I think, is their architecture. It's a unique mixture of experts and MoE setup, but it's a hybrid reasoning architecture. They built in distinct thinking and non-thinking modes.
Thinking and non-thinking, how does that work?
So it means the model can go deep, really chew on complex problems when it needs to. That's the thinking mode. But for simpler stuff, it can switch to non-thinking for super fast responses. It's about optimizing for both depth and speed, depending on the task.
Okay, that makes sense. Depth and speed. But how much info can they handle? Context window is always key.
Absolutely. And they're pretty solid there. Both models, the 4.5 and the Air, have 128,000 token context length. And maybe just as important, they were trained natively for tool calling.
Ah, tool calls.
Yeah, honestly, in 2025, if your model doesn't have good native tool calling, you're kind of behind the curve. It's becoming table stakes, so it's good they baked it in.
Right. Now, we hear a lot about parameter counts, bigger is better, etc. But it sounds like Z.ai maybe took a different path. Tell me about their architectural philosophy.
Yeah, they did something interesting. Instead of just making the model wider, bigger hidden dimensions, more experts, they deliberately reduced the width. And instead, they increased the height, the number of layers.
Deeper, not wider.
Exactly. And their finding, which is pretty cool, was that deeper models exhibit better reasoning capacity.
Mm-mm.
So it's not just about scale. It's about, well, a more efficient structure for actual intelligence, focusing on the quality of the processing, maybe.
Huh. That really does challenge the more is more idea. So beyond that core architectural choice, what else is under the hood? Any other technical nuggets making these models work?
Oh, yeah, plenty. First, the training data is massive. They started with 15 trillion tokens of general text. But then, critically, they added another 7 trillion tokens specifically focused on code and reasoning. That two-stage approach seems key.
15 plus 7 trillion.
Wow. And technically, they're using things like grouped query attention with partial rope E. These are basically fancy attention mechanisms. They help the model handle long sequences more effectively. But what's really counterintuitive is they use more attention heads than you might expect: 96 heads for a 5120 dimension.
More heads? Why?
Well, they found it didn't really help the basic training loss much. But, and this is the kicker, it consistently enhances performance on reasoning benchmarks like MMLU and BBH.
So smarter, even if not faster to train initially.
Kind of, yeah. It suggests these subtle architectural choices can unlock deeper reasoning beyond just raw training efficiency. They also use things like the muon optimizer for faster convergence, QK norm for attention stability, stuff that makes training more robust. And for inference, when you actually use the model, they have a multi-token prediction layer, MTP, that helps speed things up by predicting multiple tokens at once. Makes responses feel snappier.
Okay. That's a lot of careful engineering. But you mentioned something earlier, their reinforcement learning harness, Slime. That sounds like it might be their special sauce for the agentic stuff.
Yes, exactly. Slime. And the great thing is, it's open sourced on GitHub. Anyone can go look at it.
Yeah.
Z.ai built Slime to tackle the bottlenecks you often hit with reinforcement learning, especially for agents doing complex multi-step tasks. It's got a flexible hybrid training architecture, meaning it can run synchronously or asynchronously.
Yeah.
That's really important because getting data for agents can be slow.
Right, the data generation bottleneck.
Exactly. Slime decouples the data collection part from the actual training part. So your expensive training GPUs aren't just sitting idle waiting for data. It also has this decoupled agent-oriented design. Basically, the rollout engines that gather experience can run separately, maybe even on different hardware, from the training engines.
Parallel processing for the win.
Pretty much. It turns that bottleneck into something you can scale out, speeding up the whole process, especially for those long horizon tasks agents need to do.
Clever. And how does it generate that data quickly? Any tricks there?
Yeah, they use mixed precision. So for the data generation itself, they use the super fast FP8 format, very efficient. But for the actual model training loop, they stick with BF16 for stability and precision.
Best of both worlds.
Kind of, yeah. You get the speed of FP8 for data gathering without hurting the quality of the final trained model. And all this focus on Slime really feeds directly into GLM-4.5's and agentic skills. Makes them good at those real-world problems.
Okay, the engineering sounds impressive, the RL harness is clever, but, the proof is in the pudding. How do these models actually perform? How do they stack up against the competition based on Z.ai's own tests?
Right, the benchmarks. So Z.ai shared results across 12 common test agent stuff, reasoning, coding. GLM 4.5, the big one, came in third overall. That's behind O3 and Grok 4, and this is pretty impressive, just ahead of Claude Opus 4.
Ahead of Opus 4, wow. And the Air version?
GLM 4.5 Air ranked 6th. Still very respectable, just ahead of Claude 4 Sonnet.
That is a strong showing, especially for open weight models. Who were they comparing against?
It was decent range. Models from OpenAI, Anthropic, Google DeepMind, XAI, Alibaba, Moonshot, DeepSeek. Quite a few of the major players.
But I noticed Meta's Llama models aren't on that list, or anything from Mistral. Any thoughts on why they might be missing?
That's a good catch. It is notable. It's hard to say for sure why Z.ai excluded them. Maybe they were focusing on comparing primarily with the other leading models from Chinese labs, or maybe models with similar architectures, or perhaps just the ones they see as direct competitors in the agentic space.
Fair enough. Something to keep in mind.
Definitely. You always have to look at the whole picture. But even with that caveat, their agent performance numbers are strong. Like on agent tasks, GLM 4.5 matched Claude 4 Sonnet on bench and BFCL v3, and it really shone on BrowseComp. That's a tough web browsing benchmark.
Yeah.
GLM 4.5 got 26.4%, which clearly beat Claude 4 Opus's 18.8%.
Okay.
Yeah, and it got pretty close to a 4 Mini high, which was at 28.3%. Plus, its average tool calling success rate was the best of the bunch they tested, 90.6%. Better than Sonnet, Kimi, Qwen 3 Coder.
That tool calling success rate is critical for reliable agents.
Absolutely. It shows it can handle those multi-step workflows dependably.
Okay. Agents look strong. What about pair reasoning? You mentioned that thinking mode.
Right. In thinking mode, the numbers are solid. On MLU Pro, GLM 4.5 scored 84.6%.
Right.
On AM24, 91.0%.
Right.
And on Math 500, an amazing 98.2%.
98.2 on math. That's very high.
It really highlights its capacity for complex problem solving, yeah.
And coding. That's such a huge use case now.
Yep. It's competitive there, too. On SWE Bench Verified, GLM 4.5 got 64.2%. On Terminal Bench, 37.5%. They also did an interesting agentic coding evaluation using Claude Code as a judge.
Using an AI to judge another AI.
Yeah. Comparing GLM 4.5 against Sonnet, Kimi K2 and Qwen 3 Co were on 52 tasks. GLM 4.5 had a 53.9% win rate against Kimi K2 and really dominated Qwen 3 Coder with an 80.8% success rate. They were pretty upfront, though, saying, there's still room for improvement compared to Claude 4 Sonnet, which is fair.
Honesty is good.
And they even released that evaluation dataset, CC Bench Trajectories, on Hugging Face if people want to poke around in it.
Okay, so solid performance across the board. Let's translate that. For the developers, the researchers listening, what does this actually mean? Where do these unified abilities really make a difference in practice?
Well, like we said, big picture is enabling those fast-rising agentic applications. It's about building things that can reason, code, and act in the world. So one concrete example is full-stack development.
Yeah.
Z.ai says GLM 4.5 has comprehensive full-stack development capabilities.
Meaning
It can help create entire web apps, front-end database stuff, back-end deployment. They showed an example where it built a Pokemon Pokedex Live app. Not just functional code, but apparently with decent aesthetics, too.
a whole Pokedex. That's pretty comprehensive. Useful for rapid prototyping, I bet.
Definitely. And beyond code, creative content generation seems strong too. They highlight superior performance in generating presentation materials like slides and posters, especially if you hook it up to agentic tools to pull in live information.
Like asking it to make slides about a Tour de France winner.
Exactly. They use the example of creating slides on Tadej Pogacar's achievements,
Mm.
pulling facts, formatting them. It can also create sophisticated standalone artifacts. Think interactive mini games. They showed a Flappy Bird clone or physics simulations in HTML, SVG, Python, various formats.
Generating rentable games and simulations. That's pretty neat.
It shows it can output structured, creative content, not just text.
Speaking of creative, I heard about some slightly unusual SVG results. Something involving a pelican and a bicycle.
Ah, yes. That's a great example of the creativity, but also the occasional quirkiness. So they prompted GLM 4.5, generate an SVG of a pelican riding a bicycle.
Yeah.
They produced this whimsical drawing of a white duck or maybe a goose riding a red bike, wings on the handlebars.
A duck on a bike. Close, but no pelican.
Not quite. Still, quite imaginative.
What about the air version? Did it get the pelican right?
Nope. GLM 4.5 Air, same prompt, generated a cute, minimalist illustration of a snowman riding a bicycle.
A snowman. Okay, so clearly very creative, maybe not always literal.
Exactly. It showcased the imaginative power, but also reminds you, AI interpretations can be unique. Good to keep in mind when you're prompting.
Definitely noted. Okay, so lots of potential here. For everyone listening who's now thinking, I want to try this, how do you actually get started? How accessible are these models?
Z.ai has made it pretty easy, actually. First off, you can just chat with them for free online. Go to chat.z.ai. No account needed. Just jump in.
Free chat, nice. What about for developers building stuff?
There's the Z.ai API. It offers OpenAI-compatible interfaces for both models. So if you're used to the OpenAI API, it should be a pretty smooth transition.
OpenAI compatible is always helpful.
Yeah, it makes integration easier. And if you're using existing coding agent frameworks like Claude Code, they have instructions on how to plug GLM 4.5 into those too.
Okay, API access, chat interface, that's great. But the big question for many folks, especially individual devs or researchers, is local deployment. Can you actually run these on your own machine without needing, a supercomputer?
Right, the local deployment dream. And this is where it gets really, really interesting with GLM 4.5. So first off, the model weight space and chat versions are out there. Hugging Face, Model Scope, MIT license means you can download and use them locally.
Okay, weights are available. What about running them?
They work with standard inference frameworks like VLLM and SGLang. Z.ai has detailed instructions on their GitHub, so the tooling is there. But the real breakthrough is the quantization, making these huge models runnable on less powerful hardware.
Ah, yes, quantization.
Initially, there was buzz about a 4-bit quantized version of GLM 4.5 Air running on an M4 Mac with 128 gigs of RAM.
128 gigs. Still pricey hardware for most.
Exactly. Impressive. A strong contender for local coding. But yeah, that M4 Mac Studio is maybe $3,500. Still a barrier.
Yep.
But more recently, they released a 3-bit quantized version of GLM 4.5 Air.
3-bit, how much RAM does that need?
Just 48 gigabytes.
Or 38 gigs, that's much more achievable.
Right. They showed it running on a 2.5-year-old laptop, writing complex code. Like, it apparently wrote a Space Invaders game in JavaScript from scratch.
A full game on a laptop from 2022.
Yeah. This is huge. It means these genuinely powerful open-weight coding models. They're getting really close to being usable on regular consumer machines. Maybe not your average $500 laptop yet, but definitely within reach for many developers and researchers without needing cloud GPUs or crazy expensive workstations.
That feels like a genuine shift, democratization in action.
It really does. It pushes powerful AI capabilities out to way more people. It's a massive step for making local AI a practical reality.
Wow. Okay, that local possibility really changes the game for community adoption, doesn't it? Let's talk about that wider potential. How is Z.ai setting these models up for broad use?
Well, the MIT license is job number one, right? That removes so many barriers for commercial use, for research.
Yeah.
It just makes it easy for people to pick it up and run with it. That's critical.
Absolutely. Licensing matters hugely in open source. What else are they doing?
They seem pretty committed to openness. Open sourcing Slime, their RL framework, that's a big contribution back to the community. They're actively inviting people to use it and contribute.
Sharing the tools, not just the models.
Exactly. And releasing their benchmark data sets, like that CC bench trajectories thing we mentioned. That allows others to verify their results, build on their methods. It fosters trust and collaboration.
Transparency is key.
For sure. And when you combine that openness with the practical steps, like releasing those highly optimized quantized versions,
Right.
that 3-bit model needing only 48 GB RAM, it just makes the whole package incredibly compelling. It puts serious AI power within reach of a much wider audience. So yeah, all these things together, the performance, the open license, the community resources, the increasing local viability, they position GLM 4.5 as something you should really seriously look at for your next project.
Okay, well, we have certainly covered a lot of ground today on Z.ai's GLM 4.5 series. It really does feel like a significant step forward for open source AI. That unified approach, reasoning, coding, agents, seems particularly potent.
And seeing those benchmark numbers, holding its own against, and even beating some top proprietary models,
Uh,
that's impressive. Plus, this accelerating trend towards making them runnable locally, that's potentially transformative. It really changes who can build with state-of-the-art AI.
It really does. So the final thought for you, listening right now,
Hmm.
what does this trend really mean? If models this capable, this versatile, can start running effectively on hardware you might already own or could realistically afford, how does that change things? How does it democratize innovation? What kind of agentic applications become possible when they're not tied to massive cloud infrastructure? What new doors does this open for your next big idea? Definitely something to think about. We're excited to see what you build.